So APNIC RR or APNIC routing registry is actually part of the usual internet routing registries, and which are kind of distributed, basically distributed database and mirror with many other internet routing registries in the world. So going on to how we represent this data, or how we actually register this information into the WHOIS database, it's all based on database objects, right? So you have these database objects, and we register this information, such as your IP address information, AS number information, even routing related information, and so on, all as objects. So every of these objects, they have attributes and values, right? Attributes and values. So, and these attributes, of course, they have values, and then there are special syntaxes and so on. And of course, some are mandatory and some are optional, right? And of course, these also can have a single value field as well as multi-value fields. I will show some examples later on so you can have a look at these objects and templates and so on, right? And you can basically use these attributes and query the WHOIS database, right? There are unique or kind of primary keys, and also there are lookup keys for queries, and also there are inverse keys where we can query the database with reference to other attributes and so on, right? You can basically get the WHOIS database templates for any of these objects quite easily, right? And this is an example of a person object. I mean, this is of course an example object, right? So you can see this on your left side column. You would have all these attributes, starting in this case, person, address, country, and so on, all the way up to the source. And then on the right side, you will have kind of, person. The value of the person attribute is, in this case, test person, so the person's name, and then the address and so on, and it would go, for example, to the other attributes as well. And this is pretty much what we call a person object. So that's an example. And similarly, we can always have these kind of objects for other various WHOIS data, for example, like IP addresses, whether it's IPv4 or IPv6, and of course AS numbers and reverse DNS information, all those things. As I said, they are all registered as objects. So when you want to query these objects in the WHOIS database, there are various flags where you can use, right? And so, for example, if you want to query an IP block or an inetnum object, you can use some of these flags which are shown in the slide, because as we know, IP addresses can be represented in a tree hierarchy. So you can basically look for less specific matches as well as more specific matches, or even exact matches and so on, right? There are various flags to do that. And similarly, there are various other flags. So for example, if you want to turn off the recursion and so on, otherwise, your output can contain quite a lot of objects. So there are various keys and flags where you can do this. And then we come to the database protection. Now, it's very important when you register all these information, like your IP address blocks, AS numbers, and as well as even all these routing information, this information is protected. Otherwise, anyone can change this information. So that is why the database protection is quite important in this case. So there are some certain mechanisms to introduce the database protection. Now, in the case of course, authorization, we have an attribute called main by, right? Shown as in the slide, MNT-by, so that's main by. So this is basically a reference to an object called maintainer object, right? So this can be found in all the database objects. So whatever information we register in the database, we register using, we protect using maintainer object. And then of course, the authentication part, right? The authentication, you can use various types of authentications or various mechanisms as well. For example, like a cryptic password or MD5 key and so on. Okay, so that's in terms of authentication. Now, what are the prerequisites of updating an object? So usually, when you get the resources from the Internet Registry, first thing, they would tell you is to create a person object, right? So in other words, if you are the resource holder or if you are managing resources in the WHOIS database, you should actually register your contact details in the WHOIS database. So what you do is you create a person object, right? And so this would provide information about that particular person. Now, again, in the case of contact details, we do have different types of handles. One is what we call an administrative contact, where the person is related to the mostly handling the administrative details, whereas the other handle is a technical handle or the technical contact, where, for example, it could be a network engineer and so on, who is more of a technical person, right? So you can, in some cases, of course, one person can be doing both functionalities as well. So that's your person object. And then, of course, you create a maintain object. Now, maintain object, as I said earlier, that is to protect the object or the information which contains in that object, right? So that will provide the protection. So these are quite important, especially if you are getting resources. Make sure that you have your person object, and also make sure that you have created your maintainer object. Okay. All right. So then, so that's a kind of very quick recap. In case if you are new to APNIC WHOIS database, because why we want to actually introduce or kind of quickly discuss about the WHOIS database is basically the Internet routing registry that we are going to discuss is all about, again, it's a part of the WHOIS database that we have, and that is why you need to have a kind of understanding about the WHOIS database as well. So what is IRR, or Internet Routing Registry? So as the definition says, it's a repository or a database of Internet routing policy information, right? So when we discuss about Internet routing, obviously, there are quite a lot of things that we need to consider. So for example, like there are routing policies, agreements, and so on. And also, if you go into more technicalities or configuration level, obviously, we use autonomous system numbers, we use AS numbers to exchange the routing information via BGP. As probably you may know already, if you consider an autonomous system number, obviously, you use, inside the AS number, you use an interior gateway protocol, IGP, as well as to talk between AS numbers or autonomous system numbers, you use an EGP, like BGP in this case, right? So, and we use these routing protocols. But the thing is that, these routing protocols, there's no proper way to publish this routing information in a repository, right? So that's why we need to have kind of a repository to publish this routing information in a public place, like a database. So that's what the IRR serves for, okay? So the exterior routing decisions are based on policy-based rules, but BGP does not provide a mechanism to publish this information and communicate and so on, right? So routing registry provides this functionality. So that's the main purpose of having this routing registry. So how do you express this? Again, routing policy information is expressed as a kind of series of objects. So there we have number of objects, again, to represent or register this routing information, right? And also the routing registry would give, or this routing information would give stability and consistency for kind of routing, right? All the network operators, network engineers and so on, they can share this routing information, right? Now, there are quite a lot of routing registries in the world, right? APNIC IRR is one of them, but there are more. But the only thing is that if they are all mirrored each other. So if you kind of register in one of those other mirrored routing registries, you do not have to go and again register in another one. So registering in one of those routing registries is enough. So these are, there are quite a lot of routing registries in the world. So then we come to the point, what is a routing policy, right? So what's a routing policy? That's the way you define how you want to get routes, or in other words, traffic into your network, and then how you want to get traffic out of your network, basically, right? So it's a description of routing relationships between, again, autonomous systems, because as I mentioned earlier, we need to communicate. In the case of routing, we need to communicate between these autonomous systems. So we need to have routing relationships. So for example, what sort of relationships we are talking about here? Things like, who are the BGP peers, right? It could be your customer, maybe you are peering, or you're running BGP with your customers, or maybe with your peers, or even with your upstream and so on. And then you share these routes. So what are the routes that are being originated by those neighbors that we discussed, right? Who is importing what? So we have these imports and exports. Import is basically inbound, and export is outbound, right? So what are those routes that are being imported from your neighbors? And then what are the routes exported to other neighbors, right? And then if there are some multiple routes exist, you might want to select some preferred paths. So how do you select that, right? And then if there are no route exists, then what are you going to do, or what's the situation? And then even things like route aggregation and so on. So these are all can be included in the routing policy. So basically you need something more expressive to express, kind of a language to express these routing policies, basically. Okay, let's see now, we talked about routing policy. Let's see how we can represent this routing policy, right? So in this example, we can see there are two autonomous systems, right? There are two autonomous systems. So A is 1 and A is 2. So what we are going to do is, we are, in order for traffic to flow from the network 2, let's assume that network 2, that's in autonomous system 2, and network 1, that's in autonomous system 1, right? So in order for traffic to flow from network 2 to network 1 between these two autonomous systems, what are the criteria that should happen, right? First of all, right, AS1 has to announce network 1 to AS2 via BGP, right? Autonomous system 1 has to announce, right? You can see the word announce there. So which means AS1 has to announce its network, which is network 1, to the other autonomous system, which is AS2 via BGP, right? So then, once this announcement comes, then the AS2 can send the packets, right? So if you see now, the packet flow is actually opposite to the routes. So you announce the routes, and then the other can send you the packets, right? And similarly, the other way around as well. AS2, of course, has to accept this information, right? And similarly, in order for traffic to flow towards network 1 to network 2, now we are talking the other side, AS2 has to announce network 2 to AS1, right? And then also AS1 has to, of course, accept that, right? Accept that information and use it. And then, of course, the resulting packet will flow from network 1 to network 2, right? But only thing here is that, okay, now in this case, AS2 is announcing something, right? And AS1 is accepting something. But would you want to really accept anything but other announce, right? This is a question that we have to think about, because it may not be legitimate, for example, right? So if someone is asking you to announce something, it's a question whether you should really accept it or not. Right? So this is why it's very important that we need to check whether this information is registered in a place like a routing registry so that we can verify the legitimacy of these resources, right? So that's the main purpose. So we define these routing policies, right? So what do we use? We use a language called RPSL, right? RPSL. RPSL stands for Routing Policy Specification Language, as I said. Now these are defined in RFC. This talks about, RFC 2622 describes RPSL, right? So this is based on RIPE 181, right, which was there before. And it's kind of, you have the structured WHOIS objects, what we discussed earlier. When I was going through the WHOIS database objects, I mentioned you about the WHOIS objects and the structure and the templates and so on, right? And of course, there are a few more RFCs to talk about some of the security aspects, as well as there are some case studies and practical content is there in RFC 2650 as well, right? So it is worthwhile to read these RFCs. And let's go and discuss about some of the examples how we can define these routing policies using RPSL, right? So in this case, again, we have two autonomous systems here, right? One is AS1, you can see that. The other one is AS2. And for explanation purposes, we only show here the autonome object and the import and export attributes, right? But of course, an autonome object will have quite a lot of other attributes as well, but those are not shown for clarity purposes. So here you can only see the import and export. So if you see underneath the AS1, you can see that autonome is AS1, right? That's your autonome object, right? We register this information in the WHOIS database. So in the case of import, which is actually inbound, it says from AS2, just like what I explained you earlier, right? So from AS2 with an action preference, don't worry about this one at this stage, later on I'll explain you about this preference. From a certain preference, then you accept AS2, the routes from AS2, right? So that's your inbound policy, right? And similarly, export, which is outbound. So to AS2, you announce yourself because you are AS1, right? So you announce yourself, which is AS1. So it's a very simple policy here. So from AS2, you accept the routes from AS2. And then to AS2, you announce yourself, which is AS1, right? So that's the policy for, in this case, the AS1, right? And similarly, for AS2, right? For AS2, very similar. Now in this case, the other autonomous system is AS1. So from AS1, it is accepting AS1, the prefixes from AS1. And then export, which is outbound, to AS1, you are announcing yourself. So yourself is AS2, right? So here the action preference is actually 100. Now in the case of if there are some multiple links, for example, where you want to introduce some preference, you prefer something over the other, then you would use this action preference, right? So lower the preference, right? Lower the preference, higher, highly preferred, right? The lower the value, it's highly preferred. Okay, so this is kind of an example how you can represent a routing policy using RPSL. Now let's talk about another example here, little bit complicated than the previous case. In this case, you have 4 autonomous systems. The first one is, of course, AS123, and our focus is on AS4, which is highlighted, and then we have AS5 and AS10, right? So here the scenario is that AS4 is giving transit to AS5 and AS10, right? And then AS4 is giving local routes, or basically it gives local routes to AS1, 2, 3, right? So this is the scenario, and if you want to actually represent the routing policy using RPSL, you would do something like this, right? Our focus is AS4 here now, right? So you can see that import or the inbound, so you are accepting these routes. So from AS1 to 3, it's pretty much local, right? It's local. So with a certain action preference, you accept AS1 to 3, right? These are again, they are keywords in RPSL, right? So from AS1 to 3, you accept AS1 to 3, right? And then also from AS5, you also accept AS5, routes from AS5, right? Remember, you are AS4 here. And also in the same way, you accept the routes from AS10 as well, right? But when you announce, right, remember you are giving transit to AS5 and AS10. So in this case, when you announce the export attributes, right? Export attributes, the first one with AS1, 2, 3. So to AS1, 2, 3, you announce yourself because that's local. So you announce your own, which is AS4, right? And then, but to AS5 and AS10, it's a bit different because you are giving transit, right? So to AS5, then you announce yourself, which is AS4, right? Which is AS4 here, and then as well as AS10, right? And in the same way, to AS10, you need to announce yourself, which is AS4 plus AS5, right? And remember, of course, that AS4 and AS5, that's not a path, right? Like in BGP, because this is represented in RPSL. Okay, so that's another example how you can use RPSL to represent your routing policy. Okay? Let's take another scenario. Now, in this example, of course, we have 3 autonomous systems here. First one is AS1, 2, 3, and then we have AS4 and we have AS6, right? Now, AS4 and AS6, that's a private link. In this case, the link 1. AS4 and AS1, 2, 3, that's where the main transit link, right? And the outside is outside that AS1 to 3 is pretty much, that's the internet. Basically, you're receiving the full routing table over there, right? And then the situation is, in case if something happened, let's say to the main link, right? If the main link is failed, then you want to receive all your backup, right? Backup all the traffic over the link 1 and link 3 in the event of link 2 failure. So let's see how we can represent the routing policy for this scenario. Okay, so routing policy examples, and so we are focusing on the AS4 here, right, which is the highlighted one again. Import and export. Import, the first one, from AS1 to 3 with the action preference of 100, you're accepting any. Now here we have this keyword any. Any is to in RPSL, any is being used to represent the full routing table. Right? So that's where we receive the full routing table in the usual case, in the default case, through our main link. Right? So from AS1 to 3, with that action preference, we accept the full routing table. Right? Accept any. Now if you go to the second line, which is import from AS6, with action preference of 50, you accept AS6. Right? So now this is again the traffic coming from A, so basically the routes from AS6, right? So AS6 only. So you accept that from AS6 inbound import, right? Remember, we are focusing on the AS4. And then the third line, which is from AS6, we also have another statement, action preference 200 in this case. And again, we are accepting the full routing table, right? Accept any. Now, you can see that, of course, we are accepting the full routing table now from AS123 as well as AS6, right? But we know that our main link, by default, we want to receive the traffic from the main link, which is via AS123. So if you compare between those two, definitely, since we prefer more with AS123, that's, I mean, receive the full routing table through that, we will give a lower value for the preference there, action preference 100, comparing to the action preference 200 in the through AS6. Right? So that's how you represent your inbound policy, which is your import attributes in the Otnam object, right? And then export outbound yourself. You are AS4. You have to announce yourself to AS123 as well as to AS6. So the export line, the first one of export line says to AS6, you announce AS4, which is yourself, as well as to AS123. Again, you announce yourself, right? So that's your, in this case, how you define, for this sort of scenario, you define your routing policy using RPSL. Okay. So let's go further now. APNIC database and the Internet Routing Registry. Now, what we discussed so far was using RPSL, right? How you can represent your routing policy. So APNIC database and the Internet Routing Registry. Now, considering, first, in the beginning, I told you that we have APNIC database, we have usual, our registration information like IP address blocks, contact details, and so on. So that's all there. But in addition, you also have the routing information. In other words, Internet Routing Registry information. So in other words, you have two databases in one, right? So it's a kind of public network management database, right? So that includes all those information, IP addresses, AS numbers, routing information, and so on. So this contains routing policy information, like routing policies, just like what we discussed before, routing policies, routes. Then you can have, you can define you can publish your filters, peers, and so on. These information can be published in this repository. Right? So that's the main purpose, so that this information can be shared among the network engineers, basically, right? Whoever work with these routing policies. So APNIC Routing Registry is part of Global Internet Routing Registry. So this is kind of a graphical view of what you see in the WHOIS database, right? So you have all these IP address, number information, maintenance, and so on. And then in addition, you also have Internet Routing Registry information like what we discussed, like route objects, or routing information, and so on. I'll get to the route objects a bit later. Okay? Okay, next thing, what we need to know, we discussed about number of objects. So we have to find the relationships between these objects, right? So what sort of relationships we have between these objects? So first of all, we have our inetnum object, right? Let's go back. Let's see here. Now we have inetnum object here, okay? So you can see there's a certain IP address range here, and also, as I mentioned, it is being administered, or we have some responsible person there, a technical person. There can be an administrative contact as well. And then also it is maintained by, there's a main by attribute, which is what we call a maintainer. So it's protected. This information is protected, And then below you can see the appropriate person object, right, which refers to that person, in this case KX17AP, that's what we call the nick handle, right? So the person, so that nick handle is coming from this person object, right, for that particular person. And then also we have that main by attribute, which is main EX in this example. So that also refer to its own maintainer object, which is again listed below. So that, and the maintainer object itself has to be protected by the maintainer ID, right, using a cryptic password or MD5 key and so on. Okay, so that's your inetnum object, then the person object, and the maintainer object. Then you also will have your auth_num object. This is where you register your information about your AS number, right? So in this case, AS1, and again, you know, the person who is maintaining this, that is KX17AP, and then also it is being maintained by the same maintainer ID that we discussed, maint EX, right? And then let's say you are originating a prefix from this autonomous system, right? So this prefix, which is actually represented in that inetnum object, you can see that range, right? So that's a /24, for example, right? So that prefix is being originated from that autonomous system, which is AS1, right? So then we have to create this object called route object, right? Route object. So why do we need to create this route object? Because that's a prefix that we are announcing or originating from this autonomous system, AS1. So we create this route object, and also we have an attribute called origin attribute, right? Origin attribute, and we have AS1 there. And then also when you go further down, you will see main by, right? Main by attribute, and our maintainer ID or the maintainer object is the value of that attribute. Okay? So you can see that there is a proper kind of good relationship over there, right? So there is a prefix registered in a route object, and also there's an inetnum object for that. We also know that who the proper person is. We know the administrator, or basically the protection, the mechanism, we can do authentication there. And then of course we also know that with the same authentication we can authenticate AS1, which is actually the maintainer ID of that, which means that particular route object is originating from that autonomous system. Okay? Okay, let's go further. Now we also have other objects, right? Like set objects. So in this case I'm showing you two types of set objects. One is what we call AS set, and the other one is what we call route set. Now AS set, you can see here in this example, right? AS set, I'm defining a set of customers, right? AS-customers, okay? And then I can include some members. So if I have, it could be my customers, right? And so on. So I can include them as my members. So in this case, I have members, so AS1, I have members like AS10, AS11, and AS2, and so on. So I can include that. Those are all attributes, right? Members is an attribute. And then we have, and very similarly, we also have route sets. So the idea of AS set is you can group, right? You can group a set of autonomous systems and call it as an AS set. Right? So you group those, could be your customers and so on, right? So you group them and call it as an autonomous system, AS set. Right? And then similarly, we also have route set, right? In the same way, we can define members there. So they are basically the prefixes. So you can see in this example, there's a /20. In IPv4, there's another /20 and so on, right? So these things can be grouped as the route set, or they are kind of members of that route set, all right? Now, also when you go below, you can see that in the AS set, autonom AS10 and AS11 and AS2, they are the members because we have defined that as members. And in the same way, you will also have members in the route set. that 2/20 prefixes. Now they should have route objects, what we discussed earlier, right? There should be route objects originating from that AS2, because these are the prefixes originating from that autonomous system, right? So you have the originate attribute as AS2. And then of course that refers to the inetnum object, right? The prefixes, there are 2 prefixes here, so there are 2 inetnum objects with reference which are originating from that AS2. So this is again some more relationships between these objects. In this case we are using ASSet and route set. Alright, let's go further. Now we also, earlier I mentioned you about a maintain object or maintain ID, right? I told you about the attribute main by prefix. Now in addition to that main by prefix, we can also create more maintain objects based on the hierarchy, right? So if you want to actually, for example, if you consider the IP address blocks have been distributed from the Internet Registry to an Internet Registry member and so on. So when the Internet Registry distributes these IP address blocks, Internet Registry will protect the IP address, for example, allocation, right? Now I use the term allocation. Now allocation means basically a block of IP addresses given to a member for further distribution, right? A block of IP address given to a member for further distribution. So that's an allocation. Whereas we also have another terminology, what we call assignments, right? So assignments are IP addresses that goes into operational networks. So for example, a block of IP address that goes into an operational network or an end site, right? So depending on that, of course, let's say an allocation. So when APNIC makes an allocation, the Internet Registry makes an allocation to its member, they create an inetnum object, okay? And that has got main by attribute, right? That has got main by attribute. Usually, of course, the Internet Registry will protect that object or that IP address information. So they would put main by attribute. They'll protect it using APNICs or Internet Registries main by attribute. And then after that, when the member further delegates that block, further distribute that block to its downstreams or to its customers and so on, they can further protect that object. It could be a sub-allocation, like an allocation, right? Or it could be an assignment. If they are going to assign it to an end site as an operational network, as I mentioned earlier, they can also protect it using members maintain object. So that maintain object is what we call maint lower, right? Maint lower. And also, so I talked about 2 attributes now, 2 maintain attributes. One is main by and the other one is maint lower. And also we can have, in addition, we can also have another attribute called maint routes, right? Which is shown in the slide here. So maint routes can actually, when you create the route objects, remember we discussed the route objects before? So those route objects can be protected using the maint routes attribute, right? So we talked about 3 maintainer attributes now. One is main by, and the other one is maint lower, and the other one is maint routes. So they are kind of hierarchically, the privilege is based on the hierarchy, right? And these main routes can be used in different types of objects. For example, inetnum object. Remember, inetnum object is the object that includes IP address information, IP address ranges, and so on. And for IPv6, we have something called inet6num, right? And AUTNUM object that register the ACE or the ACE number related information, your autonomous system related information, as I showed you before, routing policies and so on. And then of course route object itself is the prefix or the prefixes that are originating from that particular ACE number, right? So all these objects can be protected. In other words, you can use this attribute main route attributes in these objects. So this is an example. So this is how you would see an inetnum object, right? So you can see there are 3 attributes in this main by, which is protected by APNIC, APNIC HM, and main lower can be an attribute from the member. And also, if they're using, they can also use main routes. It could be different attributes to protect your route objects. And you can also use the same in some organizations. Of course, they can use they use the same maintain ID for both main lower and main routes as well. So hierarchically, these attributes are protected. So this is the hierarchy, APNIC HM, and then next is main lower, and then it's main routes. Okay. So let's now see the route object creation process. Now just to summarize the things so far, so we have these route objects. Route objects contain the routing information, basically the prefixes that you are originating from a certain autonomous system, right? Now, so there are some, you need to go through multiple authentication checks, right? Because there are multiple things for us to authenticate here. That's why you need to go through multiple of these authentication checks. The first one is originating AS number, originating AS. So in this case, the maintainer in the main routes is checked. If not, remember I told you 3 types of maintainers: main by, main lower, and main routes. So first thing is it will check for the main routes, right? If there's no main routes, main lower is checked, and if there's no main lower, then the main by is checked, right? So that's how it is. And not only your originating AS number, but also it checks for the IP address space, right? Because we have to make sure that this IP address space is a legitimate IP address space, right? So that is why it checks for the authentication for that IP address range. In other words, the inetnum object. Okay, so we will basically, when you try to create the route object, you need to pass that, right? And then, of course, once it is passed, then it will, of course, check based on your maintain ID. The last part is maintain ID. It will check the maintain ID, the authentication, and if it all matches, if it passes, then you can create the route object, right? So this is the route object creation process. So if you try to sort of put that into a flow or a graphical form, first step is to create the route object. Let's say you are creating a route object for the given prefix here, which is /20 in this case, and it's originating from this autonomous system AS1, right? And we also now have to have these 2 objects in the WHOIS database. So we need to have an inetnum object to represent that IP address space, right? So you can see there's an IP address range over there. In other words, there's an inetnum object, right, in the blue color. And then also there is an autonum object that's in the orange color over there, right, autonum object. And also that has got main routes, which is given over there, right, main routes. And then you will also have a maintain ID, which actually refers to that maintainer object that you refer in inetnum object and the autonum object. So in other words, it has to match. So the second step is when you start creating the route object, it will check for the AS number and make sure that authentication is okay. And then next step is check the IP address range, make sure the authentication is okay for that range, and then after that you can basically create the route object. So that's how you can create a route object. All right, so let's go further on to using the routing registry. So far, to summarize, we discussed about the WHOIS database first, right? I briefly recapped how the WHOIS database, how the objects and so on, and then we went through the basics of Internet Routing Registry, 2 databases in one, and so on. And then also we discussed about the RPSL, routing policies, autonomous systems, and also how you can represent the routing policies using RPSL, right? And also we took some case studies so far, and then we also went to discuss about routing information, how we can register the routing information through route objects, and then A sets and route sets, right? And then we will see, based on all these things, what we learned so far, how we can use these in the routing registry, right? Now, the advantage here is that you can use all this information for various purposes, right? One thing, of course, as I mentioned you earlier, this would give us the opportunity to put all this routing information or publish this routing information where, for example, in BGP we use all the routing information, so IRR gives the way to publish this information. And also there are other advantages like various tools. So there is this tool set called IRR tool set, right? So this is actually a set of tools developed for using the Internet Routing Registry, right? But the thing is, for you to use these tools, you need to have correct information or correct routing information in the WHOIS database, right? And then once you have the correct information, correct routing policies, and so on, you can use these tools to extract those information and create various, so for example, like router configurations and so on, right? So IRR tool set. Now, of course, IRR tool says it can do lots of, it has got tools to do automated router configurations, routing policy analysis, and do maintenance and so on. Now, this is maintained by ISC now, Internet Systems Consortium. So you can actually, get the IRR tool set. You can download it from ISC website and you can start using it. Just want to focus one thing here, which is there's a tool called RT-config, right? RT-config. So that's part of IRR tool set. Now you can use this IRR tool set or the RT-config basically to use those routing policies that are in the IRR and generate router configurations, right? Now usually when you do router configurations, when the network engineers, when they configure routers and so on, you sometimes, you tend to do some typos, maybe mistakes and so on, right? If you use this kind of tool set, you might not really do much of mistakes and so on because, the tool generates you the router configuration, right? And it is more expressive, so you can even use all the filters and so on. So it's quite useful, right? And so you can generate router configurations for various platforms, right? Cisco's and Juniper's and so on, right? And you can create route maps and A-sparse filters and all your ingress and egress filters as well. So the benefits of RT-config: avoid filter errors, typos, and so on. And similarly, it is a way where you can use these, consistent policies across, because since everyone register, everyone publish this information in a repository, it's much easier to generate the consistent routing policies and consistent router configurations as well. That's one of the main advantages. Okay, now let's go into more of some practical scenarios, how we can use RPSL in practice. Now we'll take some cases or some case studies in this case to review some of the examples, right? We discussed about some of the examples earlier using quite simple policies where we define routing policies earlier, right, when I went through RPSL. And then, of course, we discussed about a bit of complex examples as well. But only thing is that we did not express those policies too much, right? And it was not very scalable because we only used particular autonomous systems. We did not consider the case where if we are going to have more and more customers, we only talked about, very specific scenario. But in the case, you might have more customers joining, more autonomous system numbers, you're having appearing with more autonomous systems and so on. In such cases, your routing policies can get quite complicated, right? So your routing policies can get quite complicated, and you have to have a proper way of simplifying these routing policies, as well as you should be able to actually have those quite scalable as well. So this is where we are trying to actually do some more of those simplifications and so on, right? So to review the RPSL, so the purpose of RPSL, we discussed about it. So that allows specification of router configurations, right, in the public database. And so to make it all consistent, right? And so it also gives opportunities to consider the policies and configurations to others, just like what we have all these tools and so on. So that's what we were talking about. Now, there are certain, when you go through more RPSL into more details, right? Even if you go and read more about the RFC, you can find there are quite a lot of address prefix range operators, because you can use these operators to express your routing policies, right? You can use that. Okay. So what sort of operators do we have? We have quite a lot of operators. I'm not going to go through all the operators now, right? For more information, you can definitely refer to the RFC, right? So these are some examples you can see. Now, if you see the first operator here, that you can use that to actually specify some more exclusive prefix in this case, right? So in this example, if you write that 128.9.0.0/16 and the operator, so this contains all those more specific prefixes, that is excluding that prefix, because there's a minus there, so which is excluding the /16 prefix, right? So in the same way that if you see the next operator down there, which is actually the plus symbol, right? So if you see that address way, that's the /8 that contains all the more specifics plus that /8 itself, right? So in this way, you can actually be more expressive, right? You can exclude certain prefixes, you can include certain prefixes, and so on. And similarly, you can also give some integers. In this case, there's an integer called n that stands for all the length of the prefix length, right? N. So in this example, you have the /8 to /16, so we can define all those prefixes which are length of 16, because we have that length 16. We are defining that using that operator, right? So you can define, or you can express your routing policy in that way. And similarly, the next operator down there, n minus m, so this can also get you a certain range, right? So in this example, 24 to 32, right? /8, but 24 to 32 prefixes. So this contains all the more specifics which are length of 24 to 32, right? So for example, a /28 or a /27 and so on. So these are pretty important, pretty useful if you have to create some filters, right? So if you want to filter some of the routes, some of the prefixes, these are quite useful, these prefix operators. And then we also have these ASPART, the regular expressions, right? Because the thing is that when you try to express your routing policies, you also have to consider about our ASPART as well. So that is why you can also use these regular expressions to match those, right? So some examples, right? Some regular expressions here. They're pretty much like those Unix regular expressions. Right? You can see that if there's a dot, that can match one character, and similarly if you have a star, that can match any number of preceding expressions and so on, right? So for example, beginning of line, $ says end of line. So in the same way, there are a number of these regular expressions where you can use these expressions in your routing policies. Again, more information about these regular expressions are available in the RFC as well. Remember those few RFCs which I mentioned you earlier, 2622, 2650, and so on. You can have, or you can refer for more information about these. Now, these are again, how you can use those AS-path regular expressions. Now, if you see the first example, which is AS3, that's with the brackets over there. So those are the routes whose AS-path contains AS3. And similarly, you can have many of those. So we will try to actually use these type of regular expressions and try to define routing policies. Earlier we defined routing policies, as I said, right? Remember the few examples I took earlier, we defined routing policies, but we did not use these regular expressions because it was only kind of very specific cases. We did not consider for number of customers, number of peers, and so on. But in the real life, you might be having number of customers, number of peers, and so on. So you want to make sure that your routing policies are quite, quite scalable, and also, they are not too complicated. We keep it at simplified level, right? So where we will use these expressions. All right, so I'll take some examples, then you will see some more information. So some of the common peering policies. So in this case, you have 5 autonomous systems, right? So you have AS1, and so that's actually not connected. That's upstream out there. You have the internet, the full routing table we receive. And then you have AS2. That's an ISP, a transit provider, right? And then also you have some customers here. So for example, AS3 is a customer, AS4 is a customer, right? So peering policies for of an AS. So in this case, the registered autonomous system, our focus is on AS2. That's which is highlighted. So we are trying to now define the routing policy for this AS2 autonomous system. Okay. Now, if you see the autonomous system here, now we are trying to remember, we are trying to define for the autonomous system 2, AS2, right? So in the case of AS2, obviously, OTNUM, the primary key, that's AS2, right? And then you go all the way down, and then you'll see your import and export lines or the attributes, right? Inbound and outbound. So import, now if I go back to this scenario, so that's the scenario. So you are AS2, right? Your upstream is AS1, okay? And then you have, of course, customer AS3, right? So import from AS1, remember AS1 is your upstream. So from AS1, you want to receive the full routing table, right? You want to receive the full routing table. So the keyword we use is any, right? So you receive the full routing table. So from AS1, you accept any. And then also you have your customer, which is AS3, right? And you also accept AS3, but then we have some expressions there, right? So if you go back to those expressions, now you'll see, if you see the expressions, if I mentioned earlier, so that's the AS path, right? That's the AS path that starts with AS3 and ends with an AS3. And of course, AS3 is the first member of the path, and AS3 occurs one or more times in the path, and no other AS can be present in the path after AS3, right? Because that's what we want, right? So that's your scenario, that's your customer, which is AS3. That's why we define that using those expressions, right? Those regular expressions. Earlier, of course, the very first example I had just had AS3 just for explanation purposes. So this is kind of much better, okay, more scalable. So that's your import. And then you have export, right? Export to AS3. Remember your AS3, that's your customer. You announce the full routing table, right? So to AS3, you announce any. AS3 announce any. And then also to AS1, that's your upstream ISP. What you do is you announce yourself and your customers. I mean the prefixes, the routes from the customers. So second export line says to AS1, you announce yourself, which is AS2, and then AS3, right? That's your customer. And then the rest are all administrative details. So basically now you have defined your routing policy, which is import and export lines, right, using RPSL. Also we have used more expressive way we have used those regular expressions. Now, there is also a scenario, remember, if you go to the diagram again, you have another customer which is AS4, right? Now, let's say another customer joins in. Earlier you had AS3, right? Now, you are going to have another customer which is AS4. Then we have to do, what do we have to do? We have to add another line, right? So, we will add another line. Earlier already we had AS3, we will add another import line from AS4, that's for the new customer. So, from AS4 you accept in the same way the prefixes or the routes from AS4. And then also export, right? Export also, you are exporting the full routing table. So, to AS4 you announce any, that's the full routing table. And then also the last one, you need to add the AS4 into your, because you have to announce AS4, that's your new customer, you need to announce that your upstream provider. So, to AS1 you announce AS2, that's yourself, AS3 one of the other customer, AS4 is a new customer, right. So, this is now you can see that your routing policy is growing now, right. Earlier we had only 2 import lines, 2 export lines, but now we have 3 import lines and 3 export lines. So, it has grown now. So, this is where we can use these AS set objects. Remember, I went through AS set objects earlier. You can put these, you can create an AS set object and include members, right. So, you can put your customer autonomous systems as members of that set object, AS set object. So, how we do it? You create object AS set, right. So, this time AS set, so we are AS2, we create a AS set object AS customers, right. We have AS customers, and then who are the members going to be? AS3 and AS4, they are our customers, right. So, that is the AS set object. Now, what do? Then we can simplify our routing policy. How we can simplify our routing policy? Because remember earlier we had 3 import lines and 3 export lines. But we can take out 2 of those because 2 of those are for very specific of those customers, AS3 and AS4, right. So, we can replace those with the new AS set we created, right. So, you would see your autonomous object AS2, import from AS1 accept any, that is fine, that is a full routing table, and then import. Now, here we say AS2 AS customers, right. We are not saying AS one line for AS3, we are not saying another line for AS4. We are putting the AS set so that we can simplify the whole thing, right. Now, next time if we get AS6 or AS7, AS8, more the customers we have, we do not have to again come and add new import lines and new export lines into our policy, right. We can always actually add that into the AS set, right. They are only one of the members of the AS set, we add into the AS set, and then we do not have to modify here, of course, because the AS set is already included, right. And then similarly the export lines, the export attribute to our customers, right, we announce the full routing table, right, we announce any. And similarly to AS1, you announce ourselves and our customers. You can see that AS3 is not in this policy, AS4 is not here. You know, those things you do not have to come and again update with your customer information or the customer AS numbers in this case, right. So, it is a good practice, okay. And then of course, from upstream side, our upstream is AS1, so from AS2, from upstream autonomous system, their policy would be from AS2, you accept AS2 plus AS2 customers. Okay. All right, so go further, now more into expressing the filtering policies as well. As I mentioned you earlier, RPSL we can use, it is quite expressive, so we can use those operators, right, which I mentioned you earlier, to actually express more specific filtering policies. So, let us look at this case. So, filtering policy. So, we have 2 autonomous systems. we have AS2 and AS3, right? So we have AS2, it's the other side is the internet, we're getting the full routing table. And then AS3, there is a certain prefix which is being allocated by RIR, right? So in this case, it's a /20, right? So that is being allocated to AS3 by the RIR, right? Now, the thing is that the scenario is AS3 wants to announce part for all of these /20, okay, on the global internet. Now, AS2 wants to be certain to make sure that it only accepts. Remember the thing I mentioned earlier, if we are trying to, if some customer comes to us and say, okay, to announce a certain prefix, we're not going to actually just announce as it is, because we don't know whether it's a legitimate prefix or not, right? We have to, this is why we have the internet routing registry, and we can actually, check for the legitimacy of those internet or those prefixes, right? So AS2 wants to be certain that only accept announcement from AS3 for address space that has been properly allocated to AS3, just to make sure this block has been properly allocated to them, and they are the resource holder, they are the proper resource holder for this particular /20, right? So this is the scenario. So we have to then create some filtering policies based on this criteria. Okay? All right. So how do we do that? Autonom object with filtering policies. Now you can see, remember the operators that we used earlier, right? You can use those operators. So we are actually, in this example, we are writing the policy, or we are expressing the policy for AS2. Okay? So AS2 from import, right? Import attribute from AS3, right? That's our other AS, this one, AS3. We want to accept only, that particular prefix, right? But also, any prefixes up to a /24, right? So that's what we want, because otherwise, one thing is, of course, we don't want to get all the small prefixes like, /27s, 28s, and so on, right? So we can then create a filtering policy based on that requirement. So from AS3, we accept only that /20, and then in the range of 20 to 24. That's your prefix length. Okay? So obviously, for an ISP with a growing or changing customer base, this mechanism will again not scale well. Remember what we discussed earlier. If you just do only one thing, sometimes if you're going to have more and more customers, it's not going to scale very well. Just like in the previous case, when we have more customers, our AS numbers, we had to put more and more import lines to define those, right? So what we did was we used those AS set objects. But in this case, similarly, if you're going to do filtering policies, you're going to deal with the route object. So this is where you will use route set objects. You can use route sets here to simplify. How do you use that? So you have route sets. You create a route set. So you can see that in this case, you have created a route set. So that's, and who are the members going to be? So the members are the prefixes that you want to get. Right? In this case, that's /20 in between /20 to 24, those prefixes. Right? So that specify all the routes that will be accepted from that given customer. Okay? So we have constructed this route set, of course, hierarchically, AS2 and AS3. That's the scenario that we have, rs-routes. Okay? So the first one, the AS2, that indicates whose sets are these, right? Whose sets. And then AS3 indicates the peer AS. Then what do you do? Then you would go and apply that to your routing policy, right? So you have your import attributes. So first, you have your from AS1, you accept any, the full routing table. Then you have your customer, which is AS3. you accept the route set, right? Because now you have certain prefixes that you have defined inside that route set. They are the members of that route set, right? So you do that for your first peer, which is AS3, and then similarly you can do that for your other peers. Let's say if you're going to have another peer, so you do that for AS4 as well, right? Similarly, when you have more and more customers, then you can include these expressions, right? So the RPSL that allows the peer AS number to replace by the keyword peer AS. There's also keyword here peer AS. Now we can see that AS3 and AS4, they are all our peers, right? So if you are going to have more and more, like AS5s and 6 and 7s and so on, where you can replace all that with that keyword, what we call peer AS. So which makes much more simpler, much more easier as well. So finally you would get your import attribute as from AS to AS customers. Remember, now this is our AS customers. We have put all that into an AS set. We are not going to define each one by one. We have put that into an AS set, right? And then you accept what routes. So that's using your route set. You're not going to put all the prefixes separately one by one. We have the route set. And then you also have put your peer AS, that's a keyword, which can further simplify your policy. You can even go further and even filter based on the interface level as well, right? So in this scenario, you have your AS1, AS2, and then also you can see that there are certain interfaces, right? So you can also actually define your routing policy based on the boundary router, for example, right? So in this case, AS1, you're writing, if the policy for AS1, so the import would be from AS2 at that IP address. If I go back to the slide, so the IP address, now in AS1, that's the IP address, in this case 7.7.7.1, right? So that's where you want to accept. So at AS2 at 7.7.7.1, right, 7.7.7.1, then you accept the prefixes from AS2, okay, and again with those regular expressions. So AS1, now in this case, of course there are two interfaces in AS2 here, if you see in the diagram. In AS2 you have two interfaces, one is 7.7.7.2 and the other one is 7.7.7.3. Now if you want to specifically say one of those interfaces, you can still do that, right? So let's say you want to accept only those announcements from the router 7.7.7.2, right? And then you want to discard the 7.7.3, right? So you do it. We add an extra one, which is from AS 7.7.7.2 at that particular IP address, which is 7.1, and then accept the AS2. All right. The last thing, actually, I've gone through a number of cases, just in the situation of multi-homing. So in this case, you have AS1, and then you have customers, AS2 and AS5, and then also AS3, right? They're all customers of AS1, AS2 and AS5 and AS3. And then if you take AS4, is a customer of AS2 and AS3. So this kind of scenario, you can also, if you want to define the routing policy for AS1, right? You can go into more, kind of pretty similar, it's all based on what we learned so far. So import from AS2, you accept, they are your customers, AS2 and AS4, and all those customers, right? So that's why you have that. So from AS3, similarly, you have AS3 or AS4 and the others. And then similarly for AS5, accept AS5 and the others. So you can define these kind of policies using RPSL. And finally, just to summarize up everything, because we are sort of getting almost to the end of the time that is allocated. So what you need to do with all this summary, using the routing registry as a best practice, so define your routing policy properly in the WHOIS database or the Internet Routing Registry, what we discussed, right? So after that, enter the policy into the IRR. First of all, you have to do a bit of planning, of course, the planning stage, define your routing policies, and then enter that routing policy into the IRR, and after that, run tools like rtconfig, right, IRR toolset, which I mentioned you, right? You can run that, and then after that, you can apply those route configs to your routers. So this is quite, it's a good way to do it. And then obviously, when you change your, when you change your routing policy, when you have different peering relationships and so on, you might want to actually go and change the, routing policy and then the IRR as well. So this, of course, will have some cost and benefit altogether. Basically, the costs are some, you need some initial planning first of all, because you have to write down all your policies, make sure you understand RPSL, make sure you can define all your routing policies and so on. So this takes some time and some resources as well. But then of course you need to again maintain this thing as well, so that also can be considered as a cost in terms of human resources and so on. And the benefits is you have a clear idea of your routing policy, you know what it is, it gives a very good global view of routing, everyone can see the same, right? Consistent configurations over the whole network, and then less manual work in the long run. Those are the important things. So I think that's about it. We discussed about the routing registry scope during this training. We discussed all those different types of ways you can define your routing policies. We went through RPSL, we went through those regular expressions, the operators, how you can create those, express those routing policies, and you can use those in practice. I've taken some practical examples. We also talked about registering those in the IRR or the routing registry, right? So, and again, most importantly, finally, this is a free service for APNIC members. So if you're an APNIC members, you don't need to, again, pay and so on separately for this service. It's a free service. So feel free to, start registering your routing information in the WHOIS database. All right. I think we are up on time. And if you have any questions, if you can take it now. Otherwise, even you can come separately and offline. I can talk to you during tea breaks or so during this week. Okay, seems not many questions. All right, and thank you very much for your participation, and hopefully you'll have a good week. Thank you.